Hello, welcome to the next episode of Living in the Future series. This time we are going to be talking about AI infrastructure. So, last time we talked about whether the technology is already there to support AI. Can AI already do superhuman tasks that currently which needs humans to do, and also whether the industry is ready to adopt it or not. Today we are going to be talking a little bit more about okay, let's assume everyone wants AI. Can the infrastructure support it? By infrastructure, I mean power, data centers, chips, or anything that's needed for deploying AI. So let's dive right inside. So Ramya, how are you doing?
Hey, I'm doing well. Just back from my summer vacation, so uh, very relaxed and excited to restart our podcast after a brief break.
Sounds good. So let's get right into the topic. For the context of the viewers, what is AI infrastructure? Do you want to give a little bit of a quick overview about it?
Yeah, for sure. I think AI, when we talk about AI infrastructure, what we mean is the physical backbone that's required to run the AI models. It could be the data centers, it could be the chips that are required, it could be the energy that's required to power the data centers. So it's essentially anything physically required or as a backbone to run AI.
Yeah, I also want to add a little bit more to that, which is how does the current AI models are processed, right? So whenever you ask a question to ChatGPT, it will effectively be converted into tokens, but and these are tokens that is being sent into GPUs, which is that's like a thousands of GPUs inside like a cloud in Iceland or somewhere. So the tokens are being sent to the GPUs, it's being processed, and you get tokens out. So effectively, when you talk about AI deployment, what you have is a token factory, as NVIDIA's Jensen would like to call it. So you have like a massive amount of infrastructure that processes tokens and gives back tokens. And yeah, the question is whether if more questions people ask, whether the current AI factory can keep up or not, whether we need more infrastructure or not. These are some of the things we're going to be talking about.
Yeah.
Anything to add?
No, I think that's a good summary. Maybe I could explain a bit more of what we mean by data center.
Yeah. That's good. And
Uh,
also, more than data center, I think it will be quite interesting to talk about what is the current status quo, right? Like, we are talking about whether we have the infrastructure or not. Let's maybe talk a little bit about current infrastructure. We have ChatGPT and various other AI models that's running. How is it running right now? Like, are the data centers right now? Are people building it? Let's talk a little bit more about.
yeah, I think when we talk about the status quo, we talk about the data centers that are being used by OpenAI, Anthropic, and like I don't know Grok, etc. So that's those are the current models, and the way that they are currently being run is they have their own data centers where they're being trained. So they buy GPUs directly from Nvidia, and they have the data centers. Usually, they have a partnership. For example, like OpenAI has a partnership with Microsoft. So OpenAI trained its models using Microsoft Azure data centers, and you have Anthropic partnership with AWS. You have Grok, for example. Like I recently, Elon Musk purchased like whole bunch of data, like GPUs, which was I think
Mm.
probably it was meant for Tesla that
Mm.
or start I think SpaceX. That's actually was directed by Elon Musk to more to run a Grok or to train Grok instead. So I feel like what we have is basically a scramble for NVIDIA GPUs. So people are like kind of even buying it in secondary markets just so that they can train the models. So because once you have a trained model, I think the amount of compute that's required afterwards is just for the inference. So the inference is basically how many users are using the AI model. So I feel like for training purposes, the data centers that exist currently are doing the job. But I feel like if the adoption of AI increases and if more applications start to use AI, then it has to definitely scale to support that. And if you, I don't think we have the infrastructure for that yet.
So, do you think currently we are good, or like we are waiting for GPUs for it to be processed, or like more people asking for, hey, can you give me this prompt and there's not enough GPUs, or we are good today and then in the future we'll need more GPUs?
Yeah, for sure. I think we definitely need more compute. That's sure. But I'm not sure whether we need more GPUs because GPUs are NVIDIA's chips. You know that there are other people also building chips, and I'm sure like you are well positioned to talk about that the given where you're working. And I'll let you answer that. But sure, like there are different companies trying to builds chips that are custom built for AI models, and because GPU was not originally built for AI. And yeah, I think we
Indeed.
definitely need more chips, and I'll let you answer the question about
Yeah, we'll
uh,
come to
chips.
that right after this. But I think you also mentioned energy that was interesting, which is so I would have imagined that before, like I delve deep into this, it's just that okay, it's like just have chips and deploy it, it's all going to be working well. But one of the things I learned was that it's power hungry. Like you need lots of energy to power all of these chips. Even if you have these chips, like you need energy much higher than the energy that will be consuming in like a household or like a, even any other industry for this. So, do you have some thoughts on that?
Yeah, I think when we talk about data centers, the unique aspect of data centers is that it consumes a lot of power. And earlier, when I first started working on data center projects like 3 years ago, the size of data centers were around like uh, 5 to 10 megawatts, and the bigger ones were of size of 50 megawatts. But if you think about data centers that are currently being designed for AI, it's in the order of gigawatts. That's actually 1,000 megawatts, and that's like a big spike in the amount of electricity that's required to power the chips that are required to run AI models.
So, how are
So
we getting the electricity today in that case?
yeah, I mean, it's definitely some countries are definitely struggling to
Mm-hmm.
keep up with it. And for example, in London, when I was working on a data center project, and I realized that in order to uh, like operate this data center, which is like 100 200 megawatt data center, they were actually waiting for the power, and the power expectation is that it will be available only after 5 years. Like it
Mm-hmm.
will take like at least 3 to 5 years for that amount of electricity to
Mm-hmm.
be granted to this data center who's requesting for this energy from an energy company or utility
Mm-hmm.
provider. And if you know if that is the kind of timeline that's required to build a bigger data center, you know that that's going to be a major bottleneck.
So,
But on the other hand, if you look at China, for example, they are able to actually bring up a new data center in a matter of 6 months. It's because of the industries that exist in China. They have continuously worked on scaling the energy
mm,
generation, distribution, all of that, because there are a lot of factories which are also very power heavy. And due to globalization, there are no longer industries in the Western world, like in the US or the UK. We don't no longer have industries, so we've stopped actually investing in expanding the energy or the energy source or energy generation. The focus was more on making the energy more from renewable energy sources, but not as much
mm.
to increase or scale the energy.
So, do you
So
think in the future there can be a situation where the world is like a seeing AI, we need AI, etc. But the infrastructure just says, hey, that's a lot of power, we don't have it. So that means either we have to price it higher or do something else to not provide the people enough AI models. Is that a realistic scenario, you think?
multiple ways to solve the energy problems,
Mm-hmm.
and people are already being very innovative.
Mm-hmm.
And if you've looked at some of the projects that were announced, it's actually people going back to nuclear energy as a solution. And because we know nuclear energy is scalable
Mm-hmm.
and it's clean,
Mm-hmm.
the only issue with nuclear energy is definitely the PR image of like people are scared about
Mm-hmm.
nuclear waste, the radiation, and what if it fails, like it can annihilate entire city and the people in it. So that's definitely one problem, and obviously there's another problem, which is the nuclear waste. It's a real problem because we haven't yet figured out what's the best way to dispose all the nuclear waste that's generated. As of now, nuclear energy is being explored as one scalable solution. And also, I think there are other projects being done by other countries where they're experimenting, like with wind energy and all of that. And I think the technology is there. It's just about like figuring out
Mm-hmm.
what's the right distribution and how do we get the infrastructure set up so that all these data center and the power requirements are satisfied,
Mm-hmm.
and a country should not be lagging behind because you don't have
Mm-hmm.
energy. That's
So I think it's just a matter of more people wanting AI and government. The technology is just there. It's a matter of scaling. I think probably we'll never end up in a situation where everyone wants to use AI, but then you just don't have enough power or whatever to support the AI. So that means the world doesn't get it. That's
Yeah, but I would say that currently, if everyone started using AI
we
at
don't have.
scale, then definitely we will struggle. But given that there are two things happening at once, there is a S curve which we discussed
Yeah.
about, like AI adoption curve. But because of that, we also have this window of time where we have an opportunity to scale our infrastructure so
Mm.
it can support the demand.
Makes sense. I actually have some more things to add to that. Like it touches the previous point on chips we were talking about, and also on the AI inference, which is the people using AI models. I don't think it's binary question of like whether people can just whether the infra is there or not, whether enough people are supported or not. I think there's many ways to stop or slow down people from using it. Like one example is the speed, right? Like you see this already when ChatGPT, when they face a lot of demand, they slow things down for specific users. So that means you get one new character every 1 second instead of like 100 millisecond. So I think that's a way for slowing down things. And another thing you see is that specifically for applications like Perplexity, I think even though the same number of users use it, people definitely want more and more faster and faster AI. That means if you want fast, do things fast, that means you need more power or like a more chip. So you need to do some innovation there. That means
Yeah.
it's obvious that they currently already have the demand to run AI applications much more faster. Like I think me personally, one of the reasons why I do use AI based search or AI based applications a lot, but I still go for Google. The reason is because Google is much faster. You get results instantaneously. I don't think today we can get results instantaneously in other AI apps. So I think that's one of the big things. We are literally limited by power and infrastructure. I think. Yeah.
Yeah, definitely. And I think it's also about the chips. For example, everyone knows like Perplexity is a lot faster than other AI
Mm.
models, and it's because they chose the different architecture, like the AI. I think you can talk
Database.
about that.
Mm.
Do you want to cover that?
Yeah, yeah, I think so. I think one thing that you start saying is that on one hand, you have more people need, even today, it's not even the future. Even today, I think the situation is there where more people want faster and more advanced models. But then you're artificially having to slow it down because the infrastructure is not there yet. On the other hand, you see lots of new demand for AI inference. So to give a context, right, for chips, the entire chip industry market is like 500 billion. In AMD CEO is projecting that just for AI inference, you would need like the demand from the market is like 500 billion. So that means there's so much market for chips to be built for like a AI inference other than Nvidia. And you see all the company which I worked with turns out like it's one of the companies that's making AI inference chip as well, and that's so much competition like AMD and ARM recently, and everyone wants to enter the AI inference game, and there's so much chips that can be built other than Nvidia for providing the AI models.
Yeah, and I think going back to Perplexity, they are currently using Cerebrus, right?
I think they piloted Cerebrus. They're not using at this point. I'm not sure, but anyway, definitely that's one big that chip is a part of their core infrastructure. Again, to
Yeah,
speed up things, right? Yeah.
yeah, because if you don't want to like, I mean, there are multiple ways to scale. Like if you don't solve data centers, but if you have the same data center and replace the chips with
Yep. Yep.
uh, more powerful ones,
Yep.
then I guess you can solve
Yep.
the scalability issue without building another building of a data center.
Definitely.
And so I feel like there are multiple levers to pull to actually scale the AI infrastructure,
Yeah.
and also companies like Meta are also trying to build their own chips
Yep.
because people recognize that the way to differentiate your model could be like the entire stack.
Yep.
It's not just about the model level, it could also be at the infrastructure level.
Yep.
You could be the one having the fastest chip that's custom designed for your model so it runs really quickly and serves people. So it's also about the cost of serving.
Mm.
If you can bring down the cost of serving in your model, then you make a lot more margin. If it takes you a lot of money to actually run the tokens and process it, you obviously have to
Mm.
charge the users for it. So you will not be cost competitive
For
with
sure.
other models. So I think
For sure.
the
I
way
think.
companies are trying to differentiate is also via AI infrastructure.
So I think previously I posed the question of imagine everyone in the world wants to adopt AI, they want need for AI. Do you think the infrastructure is there? I think I want to pose the reverse question, which is that if the infrastructure today magically 4 times, do you think you'll see visible impacts in the world? I think the answer is definitely yes, because one
Yes.
obvious thing that you'll do is that a chat GPT is much faster. So I don't think it's a good example, right? Like none of the any other use application. Let's say WhatsApp. If you send a message, you get a tick instantaneously. Let's say YouTube, you just see a video, you get instantaneously. But in ChatGPT, to give an answer, it's taking like more than 10 seconds to give an answer. I think that simply
Yeah.
proves that you don't have the current infrastructure to do that
Yeah,
business.
especially if you use like the deep search, or if you use like the modes that you use in
Yeah,
the different model also actually dictate the amount of time it takes.
exactly.
But I think another point to touch upon here is it's not just speed. I think it was also about cost.
A
If
number.
the infrastructure is like 4x of what it is right now, the
Yep,
cost would come down drastically
yep,
because of economies of scale,
yep,
and that would also help with like people using, because right
yep.
now I feel like there's a whole
Mhm.
model of credits that people are using,
Yeah,
and like the amount, like it's usage based model,
yeah.
right now everyone's being charged by the amount of usage they
Yeah.
have with
I think
companies like.
that's already happening in the sense that today a lot of companies, even ChatGPT, actually ChatGPT as well, and Cursor or AI companies are charging people much less than the thing it costs them. So if the hope that the amount of AI queries or tokens per second is being reducing massively. So I think they're all the companies are betting that the infrastructure will become better so that they can serve those things, I guess. But if it happens
Yeah.
today, that means you can accelerate the progress even more. So definitely infrastructure seems a big bottleneck to me.
Yeah, and I think maybe to counteract this
Hmm.
argument, I would say that there are other ways that are being explored too. For example, like smaller purpose-built models
Mm.
instead of having generic models answering questions.
Mm.
So you have like ChatGPT, which is like
Mm.
a general purpose one, so it's trained across like billions of parameters and things like that. But you have models, smaller models
Mm.
like Llama, or
Yep.
even ChatGPT came up with its own smaller models like
Yep.
mini models,
Yep.
and those models are actually purpose built and
Mm.
smaller, and it consumes less
Mm.
power per token, per query, all of that. So
Yep.
with that, both the training as well
Mm.
as the inference can be much more efficient. So
Yeah.
so I think even like though infrastructure can be scaled, I think the models growing smaller could also help with
Yep.
infra not being an immediate
Yeah.
bottleneck.
So I think I see the models themselves, like large models versus small models, the software that powering it, the hardware that's powering it, and the data centers. All of this is part of infrastructure in some sense, and all of them, there's been innovation happening in all of those layers independently. I think, yeah, I think that's what's happening. And I also want to add that we touched about hardware, but I also think software is like a big bit of these things. So what you have is that even if you have a large amount of models, there's a big lot of software challenges in making sure uh, like you had making sure that the queries get prompt in an optimal way to the user. You saw this in the cloud revolution when we had cloud. People were building like a software to make sure applications like video applications like YouTube or Dropbox or applications are being powered quite well. It took like some time to do. I think the same thing is happening in AI as well. The software is also like a one big layer that's being optimized, and it's getting better and better. But I don't think we are anywhere close to the thing that the user needs.
Yeah, I think definitely if you like I think the, inference like accelerator chips that are being built, I think the innovation can
Mm.
happen both at the hardware and the software layer.
So I think my view of the world is where would be in 5 years, all the chat GPT prompt will be given instantaneously. That means you can do as a user, you can ask much more questions, and that means you're not limited by waiting time of the query, but you're literally limited by amount of time you can think. I think even today, the thinking time of AI is more than the thinking time of humans, but I think that's becoming vastly better.
Yeah, and I think just one point to acknowledge here is like we've been focusing very much on the chat GPT and
Mm.
chat style one, but
Mm.
there are also AI agents that
Mm.
and
Mm.
people are working on
Mm.
architectures which is not like a chat based AI models, but it's
Mm.
much more like independent,
Things that can
independent,
do tasks.
yeah, independent like workflows, and agents can do its own task
Mm.
parallelly
Mm.
instead of like waiting for
Mm.
an input from a human. And also, there's another paradigm within that, which is like swarms of agents. So
Mm.
instead of one agent working, you have multiple agents just spawning each other and like
Mm.
working in the background. And I think
Mm.
if we want to go to those architecture, that's where like AI infrastructure becomes
Mm.
more and more important. And it's kind of, I think, a very well known and acknowledged thing among the AI community, because if you look at OpenAI, like they started this venture called Stargate with
Mm.
SoftBank and others, and what they have been doing is like they are planning to spend like billions of like dollars within like 2029 or
Mm.
something to build data centers, like
Mm.
to build the infrastructure that's required. So
Mm.
OpenAI actually already saw this coming, and
Mm.
there is work being done through these ventures that are, between like investors as well as between the companies to
Mm.
actually start building this infrastructure that's required. And
Mm.
that's where a lot of like private equity firms are coming into the
Mm.
picture, because you need people with a lot of money so that they can start building these enterprises, because it's very capital intensive.
Mm. That's interesting. Yeah. Yeah, definitely. It's not so. At this point, I think the world sees it and people are busy building various aspects of the infrastructure to serve the demand. Right? I have one more perspective to add to this, which is we talked about the infrastructure becoming better to increase or like decrease the increase the amount of tokens being processed, the results for as a user being seen instantaneously, reducing the latency and all that. I think you touched a little bit on the AI agents, but I think it's much more revolutionary than that. What I think is that one thing that we have seen as a trend is that this is a very recent phenomena, which is that more amount of processing that you do, the intelligence also didn't increases. So what you're seeing is that not even at the AI agents doing task level, even at the core AI layer level. So what you see is that instead of just giving one token and taking out one token, if you have a paradigm where you just continuously do processing and do like a thinking repeatedly, so you see it's AI is giving better and better results. An extreme example of this is that they had this benchmark called RKJ where AI was asked to solve IQ like puzzles. Turns out it was not able to solve within one day or something like that. But if you give the same AI access to lot of GPUs for 1 month, it was able to do much better and better tasks. And if you give more time to it, it's doing more better tasks. So now imagine a world where the task that requires 1 month of compute can be shrink down to 1 minute or 1 second as much as you can do. So if you have all the infrastructure for it, that means you're literally increasing the bar for intelligence, and that means you're thinking much more quickly. I think that's a scary new world that's coming, which because the proof is already there. Right now, we are not seeing it simply because the infra is not there. And if you build better chips, better infrastructure, you see much more thinking, much more results, and it can do. Yeah, that's a scary world.
Yeah, I think that's actually scaling laws basically, right? We talked about
Mm.
uh, like AI getting better. Like, what if is it possible that if you throw a lot of
Mm.
compute into the problem, like can AI get
Mm.
much better?
Yep.
So like that's one way of scaling,
Yeah.
and definitely, I think that's one way of scaling. But definitely, you need to combine it with like
Other tech.
innovation in the model level so
Yep.
that it gets more intelligent. But I think throwing compute at it, throwing more data that's like
Yep.
against the paywalls, or data that's not digitally present right now, like about the physical environment.
Yep.
If you introduce different types of data, if you introduce innovations in
Mm.
like for example, what we have right now, attention is also like a
Mm.
model innovation, right? So if
Yeah.
you need like another level of version 1, version 2, version
Yeah.
3,
So
and then you throw compute at the problem, it's totally possible that AI is going to be
yeah.
like 10x, 100x more intelligent.
Yeah. So I think the point I want to add is that we talked about the last time, right? About whether the intelligence is already there. I think, unanimously agreed that AI is already intelligent to do a lot of tasks. But I think in the context of infrastructure, I think what I think would be that today there is enough evidence to say that there's been experiments which is done to prove that AI can already do a lot more tasks given 1 month of compute time. So now I think you can't do any put it to a customer or do any usable task if it takes like 1 month to do even a simple tasks. But if the inferences infrastructure is there to shrink it there, that means you will unlock a lot of new paradigms and lot of new applications that has been not done today. And that's you see like a level two of one more wave of AI that's coming. That's just coming, which is uh, the inference on the infrastructure optimization.
Yeah, and I think we can also talk a little bit about like what are like the initiatives that are being done by different companies. Like I
Mm.
talked about OpenAI's Target, and
Mm.
I also wanted to tell a little bit about what Meta is doing.
Mm.
Meta, for example, recently announced that they are building like a 5 gigawatt data center, which is
Mm.
like we are going from 1 gigawatt to like 5 times the size, and it's called it's called Project Hyperion.
Mm.
Meta, like it's not a cloud company, right? If you talk about like Microsoft or AWS, they're already like data center hyperscalers. They're called hyperscalers, but Meta is not
Mm.
in that league. But given that now they are planning to build like a 5 gigawatt data center, it
Mm.
definitely puts them in the league of like cloud players and hyperscalers.
Mm.
And also, if you look at the people who are buying chips from Nvidia, you
Mm.
can see like Meta is is in the top
Mm.
three customers. And
Mm.
you can see that Meta, for example, their AI strategy can be just inferred based on these two data points,
Mm.
like the amount of energy that they are looking to
Mm.
have in the data centers and the chips that they're planning to purchase. That's all like giving you information about how important AI infrastructure is,
Mm.
because Meta is trying to catch up
Mm.
with its Llama model.
Do you know any initiative that's happening on the energy side, similar to the data center side, like innovations on producing new energy? Is Meta also doing that, or is someone else doing
No, I think like I talked about nuclear energy,
it?
right?
Mm.
I think Microsoft was actually Microsoft. I think it's Microsoft who's
Mm.
trying to revive like a older nuclear plant, which was
Mm.
actually almost commissioned for decommissioning.
Mm.
Basically, it was like, no, like we don't need nuclear energy. Let's shut down the
Mm.
plant. It was at that stage, but right now they're coming in. They are like, let me buy the nuclear plant, and then
Mm.
I'll build a data center right adjacent to it. So you
Mm.
have like basically a power station or generation right at the same campus of data center,
Mm.
and that's like a huge project.
Mm. I think just like the innovation that's happening on the energy and the uh, data center side, also want to add to the on the next layer, right, which is the chip side. People have been busy there as well to tap this half a trillion market, which is, I think AMD is busy building chips. ARM is now for the first time building chips. They never built chips. They only gave hardware models to other companies. Now they're building their own chips, and you see a lot of new startups like the company that I worked with, and D-Matrix, Cerebrus, and even Elon Musk's company. I think they're trying to build new chips for a lot of for like a lot of AI inference applications, and OpenAI is for sure they have like a chip product to build the new chips. So.
Yeah, I think another thing is Google's TPU as well.
Google's TPU. I forgot Google's TPU. I
Yeah.
think they're not a new people. They've been building TPUs for the past 10 years, but right now I think it's paying off because of this AI revolution that they're able to serve a lot of customers quite well because of their TPUs.
Yeah, exactly. And I think everyone's actually coming up with or betting on different things to
Mm.
improve their chip performance. And like Nvidia for now is definitely
Yeah.
a monopoly with
Yeah.
80 to 90% of chip sales.
Mm.
So you know, like
Yeah.
definitely that's a very attractive market
Yeah.
to disrupt, and
Yeah.
there are so many companies doing it. But Nvidia is actually holding fort. I feel
Yeah.
I'm actually much more impressed with Nvidia
Yeah.
because I feel like they are innovating
Yeah.
and they're scaling at
Yeah.
the same time,
Yeah. Yeah. Yeah.
and
No.
it's kind of very impressive that they are able to pull this
Yeah.
kind of thing at scale.
I think probably that gives like a good segue for some shameless self promotion here, where what I'm up to building. I think, yeah, one of the things which I'm building is also related to making chips faster. What you see is that chips are not easy to build, not anyone can build. Like, it takes like 2 years for Nvidia to build a chip, and Meta not even able to build a chip because they don't have the expertise and they are outsourcing to others, and they're struggling quite a lot. And Microsoft recently struggled. So I think one of the big innovation that's going to come in the future would be building chips in months instead of like taking 2 years to build it. And AI can help a lot in that. That means if you can accelerate the chip design process, you can get more chips, which in turn would lead to better inference and better, faster and for more intelligent AI. So yeah, and yeah, I'm not going to name my company. It's still in stealth mode, but that's something what I'm up to.
Yeah, and good luck with that.
Yes. So I think, yeah, it's quite interesting, really. I think the world we shape up, we talk from the demand side, but I think both are coming at the same time, right? Like you see that from the people point of view, people are seeing the need for AI, and AI can do a lot of these tasks, etc. And then parallel infrastructure is being built. I think we are really, really close to, or like there's a massive acceleration that's happening already in both like people adopting new AI tasks and also AI becoming more smarter, faster, and yeah, that's like a very very interesting world that we're living in. As I like to call it, right? I think there's many dimensions of intelligence. Speed is definitely one of them. Other thing is like ability to solve tasks. I think pretty much the ability to solve tasks is a solved problem in most of the domains, or if not solved, it can be solvable. And just that the speed angle is missing, and I think the infrastructure is just powering up to build things. If you can imagine the same chat GPT with absolutely no change, doing things much more quicker, that means you can already relate it to do a lot of tasks, and that's a massive new world that we are progressing towards.
Yeah.
And yeah, that gives like a good conclusion for like a new world, which is fast AI, smart AI, and that's that in the long term. But in the short term, I think there's so much opportunity there in energy, infrastructure, chips, things, and there's a lot of new things to be built for the new world that we're living in.
Yeah, it's exciting times for sure in the infrastructure space. as well as the application space, which I'm sure we'll talk about in the
Yeah.
next episodes. But yeah, hopefully everyone found this useful.
Yeah. And that's all we have for today. Thanks, everyone. Bye bye.
Thank you. Bye bye.